Hello everybody. Today we are going to be doing lesson 2, which is intro to the commands, and I believe it's turning on an onboard IO LED. Now, make sure you've watched the previous video on how subsystems and commands interact. But this is probably the first easiest lesson that you're going to be able to get for the Romi. Now, make sure you have it on. Make sure you check the number. Mine's number 1. So what we're going to do is go into VS Code, and let's not connect to it yet, but we're trying to turn on an LED. So the first thing we need to know is what button we're going to press to do that, and that obviously starts in robot container. And I think I include a controller already. It's on port 0, so that's your keyboard in this case. And I call button number 1, I think it's Z, but you can change to which button it is in the little simulator environment. It's called button name for me. You can call it Z button, whatever you need. But down here where it says put button bindings here, we're going to write the actual button. But first, before we do that, let's create the command, because we're going to create a command that tells onboard IO to turn on an LED. So let's go to telecommand. Since you're going to be controlling this, you can put it in telecommands. Doesn't really matter where you put it. But it's going to be an instant command, but we're going to just do a command for right now because it's a little bit easier to understand than an instant command is. So we're just going to do command, and we're going to call it LED on, I guess. Let's do LED test. Make sure you're using Pascal case for commands and subsystems, which is the first capital letter is capitalized. Still doesn't really matter, but if you just keep that consistent, then you're going to be able to recognize what things are a little bit faster. So we're going to call it that LED test. Now, the command is going to need to know which subsystem we're using. And the way it does that is by taking in a subsystem in this little parameter thing. So this is where you're going to be importing all of your stuff. Now for this, we're only going to be importing the subsystem. For other things, those are more advanced commands. We'll talk about that later. But you can import other variables too, like booleans, doubles, and for whatever reason you want. Maybe you press a button and you want it to go at this speed, and then you give it a 0.5 speed, or maybe a 0.75 speed, and you put that in here. Well, right now we're just turning on an LED, so we don't need any of that. We're just going to put the subsystem. So the subsystem we're using is onboard IO, and be very careful to click on frc.robot.subsystems, because this right here is the built-in one, and hopefully it does it for me. Okay, it did, because we're using our own subsystem onboard IO for this, and we're going to call it also another thing we're going to talk about, I'm going to call it local. And the reason I'm calling it local is when we're importing variables into these parentheses here, they're only going to exist in the code in this scope here, between these curly brackets. And it's not very useful when it's in there, because we want to do it in one of these states down here, initialize, execute, or end. We want to put it in those too. So the way we're going to do that is, the scope that we need is this one, this gold curly bracket. That extends throughout the whole command. So what we're going to do is make a new variable of the same type, onboard IO. It's the same subsystem. We're going to call it global. Now in the example code on the thing, I think we call it capitalize the B. I think we call it S underscore onboard IO. That's better practice than what I'm doing here. I'm just trying to show you how scope works in Java. So if we say, now that we have this global variable, we need to set it equal to the local variable so that they're the same. So we say global equals the local. Okay. And now that that's true, we can use global in any of these states here, initialize, execute, and end. So then we also have to add global. Got to add the requirements for it. And that just means that we can use the subsystem now. So now that we've added the requirements and we're using onboard IO, we can now use any of the methods, which are the things inside onboard IO. So there's a few different ones. There's set green LED, set red LED, set yellow LED, and set servo. We'll do servos later. They're pretty fun. But right now we're just going to use any of these three. So you guys can choose which ones you want to do. And they're declared up here. So the subsystem knows which port the LEDs are on. So it knows the green LED is on port 1. It knows the red LED is on port 2. So that it can output the correct thing. You can swap these around and see how it changes the code. Because then instead of doing the green one, it'll do the red one. Even though it's still called green LED. Because these are just names. But now that we're going to use these methods, we can actually just copy the name from here if we want. Or we can just write it out. I'm actually going to write it out for you, LED test. So we're going to go down to execute for now. It'd be more efficient to put it in initialize, I suppose. Because all this thing's going to do is we're going to call it once. So it's an instant command. So this condition right down here, if this thing returns true, the command stops. So we could say if 1 is greater than 2, that's a divided by. If 1 is greater than 2, which isn't true, it'll return false. So this will never end. But if we just say true in here, it'll always end like after 1 round. So it doesn't matter what we put in execute. We'll just put in initialize. So we'll say onboard IO, which is our subsystem that we just did. Actually, no, sorry about that. We called it global. And global is our global subsystem, so we say dot. And now we can see all of the things that were inside onboard IO. So we got the servo in there, and we have the set red LED and set yellow LED. Just pick a color, doesn't really matter. And then what we have to give it is a Boolean value right here. It's asking for Boolean values, so it's true or false, and we'll say true. We'll turn the red LED on. And just to add something else to it, we're going to try and put in set green LED. We'll turn the green LED off. And you could add a yellow one in there if you want. But for right now, this is our command. It's going to take in the subsystem, and then it's going to call this on initialize. It's going to turn on the red LED, and it's going to turn off the green LED, and then that's going to use the onboard IO to do that. So there we go. But now we can go back to robot container, and we can use that button that we made. So we got button name, and then dot on true. So if we go to on true, there's a few different ones. I'm not sure what these ones do, but on true, oh, it's a toggle. So you press it and it stays. Press it again. So it's on true, on false, on change. We're going to use on true for this one. So when we press the button, we're going to say it's a new command, but we're going to call the command LED test. And this is going to take something called local, which is actually our M onboard IO that's declared up here. So it's going to import that for us. And there we go. There's our thing. We press this button, it calls LED test. LED test calls set red LED and set green LED in the onboard IO. And then it does the stuff. So now we can turn on our Romis and connect to it. Mine's number 1. Let's hope that it shows up here. Romi 1, there it is. And we're going to connect to that. Make sure it's actually connected. We're connected. And then we're going to simulate it. And just pay attention to the lights on the Romi that show up while you're doing this. Because we got the yellow one that's on. And if we set it off, it should turn off for us. But we just have the green and the red one in the code. And let's hope this doesn't take too long. So if you look in this folder here, what we're going to do is, you can walk through these videos and this thing if you want. But the different challenges, I want you guys to play around with this a little bit, mess around with some different colors. And I also want you to, at the end of this, make it so you press the button, and then when you press the button, it turns on, and then when you take your finger off of it, they turn off again. So it's, you click it, turns on, take it off, turns off. That'd be really cool. And the way you do that is by using two commands, and you're going to be using the on false as well as the on true buttoning. Okay, so that would be number 2, and then number 3 is, you know, kind of same thing, just a little bit different. And then what I want you guys to do is take a video of it working and then put it into the Google Classroom. So this is just like examples of it actually working. So if we go into the Google Classroom here, in these little Romi lesson things, you can add videos to it. So Romi lesson 1, it's just you driving around, but then these are the challenges. So you can add, you can add the videos of those things doing it. Some other things here. I think that's pretty much it in terms of turning in stuff. I'm not grading anything. This is just for future people who want to, you know, learn the program, and it just helps me out a little bit. What else? Okay, build successful. Let's see if this actually works here. Okay, we're opening stuff. Okay, so if you look at the Romi, these lights turned on right away, which is a good sign. That means it's uploaded and it's working. If we put our robot state to teleop, we should be able to control it. Let's hope it works. Okay, we can now control it, and now let's try our button. Would you look at that? The green one turns off and our red one turns on. Well, it stays on. We don't know if it turns on because it never did. But if we look at our code, we can go to disabled mode. If we look at our code, we told it to, let's see, LED test. We told the red one to stay true and the green one to go false, which is exactly what happened right here. So mess around with it, upload your videos. Yeah, have fun with it.